Alrighty, as we discussed in class, the equation of a circle is defined as being x minus h, quantity squared, plus y minus k, quantity squared, equals r squared, where h and k are the center, and r is our radius. I'm going to do a couple problems on this first page just to remind you of a couple quick things, and then I'll move on to the back page because I know that a couple of those problems were a little bit tricky. So looking at this, if we look at the first problem, that one, we see that the center is at 0, 0, and r equals 8. Now we know that x minus 0 equals x, and the same is true for y. Y minus 0 is y. So we can actually write that as just x squared plus y squared equals 8 squared. That one everybody seemed to do really well on. The thing that I saw that was really hard was problems like number 5 and 6, especially looking at the negative sign. So what I'd like to remind you all of is that minus a negative equals a positive, and minus a positive equals a negative. So we're looking at that minus sign. Here, I'll do a different color to help it out. We have a minus sign there. So we want to think about what our number is. So a negative 3 will go to x minus a negative 3 squared plus y. And looking at this, it's a positive 5/8, so we have minus positive 5/8 squared equals, and this one was really tricky. The diameter is 12 and our radius is half of the diameter, so radius equals 6, and we have 6 squared. This minus a negative, here I'll redo that in a different color just as a reminder, minus a negative can be rewritten as plus, and we can just say that it becomes positive, like we have over here. Those were the two biggest things that I noticed. We're really watching out for where it says diameter and watching your negatives. Overall, I would say that, oh no, it's not connected. That's okay. Overall, I would say that the rest of this went pretty well. People seem to be doing all right with the graphing problems, and so I'm going to move on to the next page here. And so if we look at page 2, you'll notice that these first two problems, number 1, and number 2, were probably the most challenging. Number 1, the secret here was to use that formula of the interior angles of the sum of the interior angles of a polygon is equal to 180 times n minus 2. So that just means that all of the angles added up in this polygon with 8 sides, this one would be 180 times 6, which would be equal to, let me just double check my math real quick, 1060. And then to find the angle measure for just one of these angles, we would divide that by 8, and we'd get 135. Now that would just be for one angle. And now here we can see that we have a linear pair or supplementary angles right here because they make a line. And anytime something makes a line or it's like a turn, like halfway around a circle, it's going to be 180 degrees. So we can find f by subtracting 135 from 180. So I'll just mark this one here as being a total of 180 degrees. I'll make some notes off to the side, E, F, G, and H. And so 135 taken away from 180, or 180 minus 135, is going to mean that F is valued at being 45 degrees. And over here, if we had done the same formula for our sum of the interior angles of a polygon, we would see that each of those angles is 108 degrees, and so we can find E in a similar manner, taking 180 and subtracting away 108 to get 72 degrees. Now we want to look at our centerpiece here, where we have an angle of 108 and an angle of 135, and we have G missing. To find G, we should think of that as making up an entire circle, and a circle has 360 degrees in it. So we take 360 and we subtract away 135, and we take away 108, and we're left with 117 for G, 117 degrees. Now we're only left with H. And H, to find that, we have to think about what size and shape is our figure. What kind of shape is it? How many sides does it have? And this has 4 sides, which means it's a quadrilateral. And so we know that that's going to have 360 degrees in it. And so we'll add up all of these numbers, our E, F, and G, and take that away from 360 to be left with H. So we have 360 minus our 72 minus 45 minus 117, and we will end up with 126 degrees. And I know that many of you got that, and that was wonderful, but those were just some helpful hints on figuring that one out. Now, moving on to number 2. This one I think many more people struggled on. Almost everybody missed this one. And I think that that is because of the way the picture's drawn. And so I'm going to extend the lines so that it looks more like the parallel line problems we've been dealing with. So I'm just extending out the lines straight away. My stylus is not the best, so it gets a little funky, but we can kind of get a better idea of what the shape would look like if it was just some parallel lines. And right away, I'm going to notice some corresponding angles. Those are angles that appear in similar placement in comparison to their parallel line along the transversal. So a transversal is the line that's going to intersect both of the parallel lines. And so we see that 44 and D, or 44 and the angle adjacent to D, are corresponding, so that we know that this is 44 degrees as well. Now we see that 44 and D make up a line. They share a line, and so they are, and the line that they share is this one that I'm talking about right here. And so that is going to make 180. So we'll want to take 44 away from 180, and let me write out some notes on the side again. We have A, B, C, D. And I'm going to say that D is 180 minus 44, so it's going to be 136 degrees. And that's a great start right there. And so now we have most of the angles of a quadrilateral. The only one that we are missing is right here, because we know the measurement for D and we know these bottom two angles. So what I'd like to do next is take those angles that we know away from 360 again. So we have 360 minus 52 minus 96 minus 136, and we are left with 76 degrees. Write that in there, 76, and that is for this angle right here. So then again we have some angles that share a line, and we can see right away that C and 76 are on the same line, so they would equal 180 degrees when we add them together. So we can take 76 away from 180 to find out that C is going to be equal to 104 degrees. Sorry about that. Alrighty. Last but certainly not least, we have A and B left to find. And the reason that I marked those two like that, I'll give them one more marking, is because these two angles are alternate interior angles. They're inside the parallel lines, and they're on opposite sides of our transversal. So they would be congruent, and that's a property of lines and angles that we should know. So looking at that, we have to think, which one do we want to find? And we could find either, and I'm going to find B because we just found C. And so we know that the measurements of a triangle are equal to 180 degrees in total. And so we're going to take 180, we're going to subtract away 44, and we'll subtract away 104 for C. And we are left with 32 for B. And because B and A are congruent, because they're alternate interior angles, we know that A is also equal to 32 degrees. And that really finishes up that problem, and we've found all of the parts and pieces. So, move this up a little bit. The only thing that I would also like to just double check on real quick is that everybody remembers that a perimeter is just going to be the sum of all the sides. And that when we take 73 and 34 away from 180 to find our missing angle, T, that this angle is also going to measure 73 degrees. And we'll write that twice down here too. And now we see that we have a triangle with two identical angles, and those are going to be congruent because they're equal in measure. And then we have an isosceles triangle, and I know I showed this to a couple people, but just to make sure everybody sees it. When I see an isosceles triangle, and I hope that when you see it, you think that if two angles are the same, then two of the sides are the same, and they're going to be the opposite sides. So we draw arrows from our angles across to the opposite side. So we know that 10.4 is equal to y plus 5. And I saw a lot of you solve this setup correctly. And then, just a reminder, when we say sum of all the sides, that means you have to add y and y plus 5 and 10.4. And you have to add all of those together to find the perimeter. those were really the big things that I noticed, and if you had trouble on number 3, I would still say that looking at the other examples I did would be really helpful, because those problems will help you solve this one too, because it's just the same strategies. Alrighty, thanks for tuning in. If you ever need anything from me, please let me know. Thank you. Bye.